Yo, what's up? It's your boy, Mr. AC. And what I got for you guys today is going over primarily, and we are on year number. So let's go ahead and get started. Let's get started on this one here, which is a very different style than the ones that we've been accustomed to now, right? Because the other ones were giving you G equals F. That's our second fundamental theorem of calculus that we have to use. This one is just a little bit different. So let's go ahead and try to process through. The figure above shows the graph of F prime. So they're giving us F prime, the derivative, and the graph of F prime has horizontal tangents at x equals 1 and x equals 3. The function F is twice differentiable with F of 2 equals 3. They give us an initial condition. This to me tells me, just so you know, this to me tells me if they're giving me F prime, I'm probably gonna have to go backwards because they're giving me an initial condition right here. So keep that in mind. So let's go ahead and get started. Find the x coordinate of each points of inflection on the graph of F. Well, points of inflection, if you look here, it's asking about F. So for part A, we need to find when F double prime changes signs, right? From positive to negative or negative to positive. I gotta take the derivative of this graph. Well, the derivative right here would be 0. The derivative right here would be 0. And if I look here, this goes from positive to negative because I'm taking the derivative. This is our second derivative. This is F prime. So we're taking the derivative. Positive to negative, negative to positive. So this right here, let me go ahead and write it down now, will be this. The graph of F has points of inflection at x equals 1 and x equals 3 because F double prime changes signs at those values, right? They change signs. So we know that has to be points of inflection. That was our second derivative. So hopefully that makes sense because we're going to go ahead and move on to part B. Moving on to part B, the figure above shows the graph of F prime, the derivative of it. Oh yeah, sorry. Right here. What values of x does f attain an absolute minimum value on the closed interval? At what values of x does f attain its absolute maximum value? Show the analysis that leads to your answer. Holy crap, that's asking for a lot. It's asking for the biggest y value and the smallest y value. So we're gonna have to check, just if you did the prior video, that means we need to check our endpoints and we need to check our relative mins and maxes. Well, we just took the we're given f prime, right? So let's think about this for a moment. How do we get our absolute min or maxes? Well, we need to check what has the biggest or smallest y value of your like these interval points right here. We need to find out the relative mins or maxes because we don't know how far they dip or not, right? We don't know if the relative mins dip further than the endpoints. So nonetheless, how do we get them? It's talking about f. How do I get my relative mins and maxes? I need to take the derivative. So this is f prime. Well, this is the graph of f prime. So really, if I look here, what does this change from? This changes. So this is where you have to be careful. We are in f prime right now. This is where it can get really confusing. So hopefully this is making sense. Anything down here is negative. Anything up here is positive. This is referencing our first derivative because we're finding our relative mins or maxes, right? The first one was second derivative, so we took the derivative. Since we're given f prime, anything down here is negative, anything up here is positive. So this is negative to negative, this is negative to positive. So this is a relative, if I draw a little graph at this point, negative to positive, this is a relative minimum. So I know at 4, this is a candidate because I have a relative min here. This goes from negative to negative, so I don't have to worry about it. And there is no relative maximum. Nice. All right. Now what we have to do, what we need to do is we need to figure out these endpoints. How we would kind of start it off, right? We will need to find f of -1. I'll start with -1. Well, I'm going to leave some space here. I'm giving f prime. So what do I need to do to go backwards? This is what I was talking about. We need to go backwards to f, which means we need to take our antiderivative. So I'm going to write the antiderivative of f prime of x dx. I'm going to put the -1 up on the upper bound because that's what it's asking for. And the question is, what is the lower bound? Well, this is the problem. They don't give us a lower bound. Well, remember, they gave us an initial condition right here. So if this is 2, the 2 goes here, and this is going to be 6 plus, right? I put the 2 here because it gave me that value, and 6 is the y value. That's where the function started at. So we have some initial point to put our integral. Once we've done this, well, we need to go from most positive to most negative. So this is going to be 6 minus, let me go ahead and write this out, -1 to 2 f prime of x dx. Well, How do I go about doing this? Well, I'm given the graph of f prime. What does the antiderivative tell us to do? It tells us to find the area under the curve, right? From -1 to 2. From -1 all the way to 2 right here. So we need to find this area under the curve. We don't know what these area values are. It's gonna be really, really hard to figure out part B now because we don't have areas and we're having to kind of approximate this, if that kind of makes sense. I did this on purpose to show you what you would normally do, but really, to be honest with you, when you would start this problem and you notice that they don't give you any area, that means you need to start to do some estimations, very similar to what we did in the very, very first video of this. So let me show you what we're going to do to figure this out, okay? We're going to sketch this. Now, we know this is f prime, right? Anything down here is negative. Anything up here is positive. At 4, we have a relative minimum, right? So this is from negative to positive. Now, this is where we have to kind of try to figure this out to the best of our ability here. So how are we going to figure this out? Well, we know that it is decreasing. The graph is decreasing from -1 to 1, right? So we don't know where it's at. We do know at 2, right? The y value is 6 right here. So this leads me to believe, right? This leads me to believe that this is decreasing, meaning the graph should be looking something like this. I kind of drew it over. It's decreasing, decreasing. Obviously, the slopes are varying. It goes to 0. So maybe this graph goes to 0 like this. Let me go ahead and change the color real quick. So it's going to look something like this, just kind of drawing it out. Again, this is a very tough one, right? I know I drew this kind of poorly. It's going to look like this. Oh my God, that was bad. Decreasing, decreasing, decreasing because it's underneath here. It reaches 0. So it's going to hit 0. It's going to make this curve, but then it's still decreasing again. Since we are decreasing again, we're going to continue to decrease like this. So far, this is how our graph is looking like. And then it's going to decrease all the way down again until it hits 0 at 3. So down here, again, I don't know how this is looking like, but I know it's going to decrease, blah, blah, blah. It's going to hit 0 at 3 right here. Boom. And then it's going to decrease again even more, right? This is going to decrease even more. Obviously, the slopes are changing, so we're going to continue to decrease. And once it hits 4, once we hit 4, right here, then it's going to, well, what is it going to do? Well, now it's going to start increasing, right? At 4, it's going positive. So now we are going to be increasing right here. So then this graph is going to look something like this until it gets to about 5. If we draw this graph, we kind of had to draw the original from f prime to figure this out. If we draw this graph, I can conclude that the absolute minimum value has to occur at -1. The absolute minimum value has to occur at 4, right? Because 4 is where it's going to have the biggest dip at. You can already tell because at 2 it was 6. It should have been up here. So you know at 4 has to be your relative absolute minimum. And our absolute maximum had to be -1 because we know this point is probably somewhere up here. We don't know what that is, but we do know that this right here is going to be our absolute maximum right here. So we have our absolute minimum and we have our absolute maximum. Now you might be asking yourself, well, how do we explain this? Well, let me show you. So what we're going to say here, okay, which is really, it's going to be tough, right? We're going to say that the graph of f is decreasing from -1 to 4 and then increasing from 4 to 5. So we're going to describe this. The graph of f, oh my God, did I forget to put f? The graph of f is decreasing from -1 to 4 and then increasing from 4 to 5. Or you could say the graph of, in the graph of f prime is negative from -1 to 4, and f prime is positive from 4 to 5, whatever language you want to use, right? It's decreasing and then increasing, right? Then we can say, therefore, at x equals 4 is the absolute minimum because it's the lowest y value in this interval, and the absolute max is at x equals -1. And this would be our final solution right here. So our job is to state hey, this is decreasing all the way down, right? So that means -1 has to be the highest point. You don't need to justify that part, but you do need to state what basically happened. Well, it's decreasing, right? All the way from here to here, and then increasing from here to here, and then these are my absolute min or max. You'll notice these problems were actually really, really tough, right? These ones, in my opinion, with these absolute mins and maxes are pretty brutal. Hopefully you make sense of these. These were in the 2004, 2003 years. They can be pretty tough. Let's go ahead and finish up part C. Let g be the function defined by g of x equals x times f of x. Find the equation of the line tangent. Equation of the line tangent is y minus y1 is equal to mx minus x1. Now they told us g is x times f of x, so we have to be a little bit careful. So nonetheless, if I was to kind of write this out, this would be y minus 6 is equal to mx minus 2. The 2 is my x value. That's what they're referring to right here. And the y value is 6. So there it is. How do we find m? To find m, you need to take the derivative of this function, right? Take our derivative and then plug in the value to get our instant slope. But here's the kind of the issue that we have here. If I take the derivative of this, this is gonna invoke the product rule because we are multiplying two functions. So g prime of x is equal to the derivative of x is 1, leave the second alone, plus leave the first alone, derivative of the second is f prime of x like this, okay? And we're gonna plug in 2. So g prime of 2 is going to equal f of 2 plus 2 times f prime of 2. Now here is the good news. Hopefully, this is a tough one. F of 2 was already given to us. F of 2 is right here. Boom. F of 2 is 6. So this is 6 plus 2 times, well, what is f prime of 2? Well, we're given f prime. So this is the graph of f prime. The y value, f prime of 2 is -1, right? This value right here. So this is -1. So this is going to be 6 minus 2, and then we get 4. That is going to be my instant slope. So I can go back here and write this as 4, and then this is going to be x minus 2 right here. And then now we have fully completed this problem, A, B, and C. A pretty dang tough one, but hopefully y'all enjoy, and hopefully it's all coming together. Understanding that part B is a little bit tough, okay? It is pretty tough. So take care. Capiche?